Welcome to Flipped Classroom. Our unit is measurement and we are looking at the volume of prisms and cylinders. Our learning intention is we are learning to find the volume of simple 3D shapes, and our success criteria is I am successful when I can calculate the volume of a 3D prism and can calculate the volume of a cylinder. So looking at these 3D shapes, I want you to think, what is the best shape for their bases? So for our triangular prism, it's quite easy. It's a triangle. For our rectangular prism, it is a rectangle. Now this could also be a square, and it doesn't really matter which one you choose as the base. And for our cylinder, the best shape for a base is the circle. Now, volume is the space inside a 3D object, and we measure it in cubed centimeters. Now, here's an example of a cubed centimeter. It's a cube that is 1 centimeter in all dimensions, and we do call it a cubic centimeter, not a centimeter cubed. Now, the volume is the amount of space that is inside, and we measure it using these cubic centimeters. And for simple solids, we could just cut it up into those cubes and then count the number of cubes that we have got. So as I said, we've got cubic centimeters, but we also use cubic millimeters, cubic meters, and cubic kilometers. Now, the volume of a prism can be found by multiplying the cross-sectional area, which is the base, by its height. And we get this equation, volume equals A times H. As I said, A is the area of the base, even if it's not at the bottom of the prism, and H is perpendicular to the base. So using our triangular prism there, we can see that triangle that is all the way through. So we say that that triangle is the base, and if we work out the area of that and times it by the height, we've got the volume. Let's have a look at a worked example. So here's our triangular prism. It's the same triangular prism we used when we were looking at surface area. And on the left, I'm going to do my thinking, and on my right, I'm going to write down what I show my teacher. So my first thinking is I need to calculate the area of the base of this prism. So I remember that the base is that triangle, that 3, 4, 5 triangle. And to work out the area, I need to use my triangle rule, which is half base times height. Now the base of that triangle is 4, the height is 3. So I multiply that through and I get 6 centimeters squared. I then need to multiply that area by the height of the whole prism. Now the height of the whole prism is 8 centimeters. So I get that 6 centimeters squared times it by 8 and I get 48 cubic centimeters. Now you'll notice that we didn't use that 5 centimeters at all because that's not one of the dimensions we needed to worry about. Sometimes they'll throw in those extra numbers just to confuse you. You need to work it out, and this is where drawing it can help. So let's look at a different example here. We've got a hexagonal prism, and they've given us the area of one end. We don't have to calculate it. So again, I'm going to do my thinking and my writing. So my thinking is I need to write down the formula for the volume of a prism, and I'll write that down. And then I'm going to substitute in that area and height. So I substitute it in, type it into a calculator, and I get 320 cubic centimeters. Now for a cylinder, it is very much similar to a prism. So first off, I'm going to calculate the area of the base of this cylinder. So I'm going to draw up my circle, and I've put in radius because I know I need radius for the area of a circle. I'm going to write down my equation, area equals pi r squared. I'm going to substitute in the numbers, and I'm going to leave it in a rational form. And the reason for this is I want it to be as accurate as possible. Now next, I'm going to multiply the area of the base by the height of the prism. So there is my volume equation again, and I multiply it through. Now I've rounded off to 2 decimal places there. I do have a slightly more accurate number there, which has 6 decimal places, and we'll see why that's important when we start working out the capacity of this tank. So I've just moved the equation up there so that we've still got all of those numbers. So let's convert meters cubed into litres. And we know from the video about converting that 1,000 litres is in a meter cubed. If you want to review that, you can click on the link at the top. So I'm going to work out my capacity by timesing it by 1,000. And it does say to the closest litre, so I'm going to round that off. And I get 68,707 litres. Now, if I used the rounded version of the volume to that 2 decimal places, I would have got 68,710 litres. So it would have been 3 litres different. And this is why you shouldn't be rounding until the very end. Our reflection for this is, why does knowing the surface area and volume help with creating designs for packaging? As always, like the video and subscribe for more videos on maths.